So when we talk about exercise 305 with the equation solving with the complex numbers, it's going to get a little bit sticky. So I wanted to walk you through one of those, especially problem B. You look at the answer line for that one. It's pretty out there, but that's okay. Let me walk you through this real quickly here. So we'll take this. All right, we got that 4 minus 1/2 I times z. That's the variable. The z is going to be the variable here. And I've got this minus 1 over root 2 plus I quantity right here equals, oops, didn't mean to do that. And darn it. There we go. Equals 2 minus 1 over root 2I. All right, so with this, we should tell you what we're going to do here with that quantity. We're going to go ahead and just cancel that out because one of our first objectives whenever we're equation solving is always we're trying to get rid of the everything that's around the variable. So in this case, if I just add this quantity to both sides, I mean, it should just cancel that right here, but it's not just gone away altogether. Of course, now it's over here. It's over 1 over root 2 plus I. Okie dokie. So now with this problem right here, as I look at this, one of my first instincts is to try to rationalize denominators, and well, it'd help if I had the same denominator. And in that regard, if I rewrite this as 2 root 2 over root 2, that's still 2. I think you can agree with that. And with, let's see, I'm going to go ahead and push this over here and just say plus 1 over, I'll say 1 over root 2, like so. And I still have that minus 1 over root 2 times I plus I. All right. And, ooh, I have the same denominator except on the end here. So instead of that plus I, I'm now going to write it as root 2I over root 2. How's that? And I'll eventually clean it up a little bit. But all right. So now on the right-hand side of this equation, as you can see, I now have a single denominator of the square root of 2. And what's the numerator? Well, it's going to be 2 root 2 plus 1 minus I, and then I'll have plus I root 2, like so. Over here on the left, nothing's changed too much. I'm just going to write 4 minus 1/2 I, all in quantity, times z. And at which point I should start realizing, say, hey, wait just a second here. If I take this, let's scoot over a little bit. And actually, I'll take this and scoot it in. I'm going to take the multiplicative inverse of 1 minus 1/2 I. Now you may say, wait, how do I know what that is? Well, that's the point. We don't really need to know what it is. I'm just going to go ahead and declare that I'm multiplying both sides of this thing by 1 over 4 minus 1/2 of I, like this. And now that will get me down to just z. Now, what's z exactly? Well, that's going to be, present the new challenge for us here. One of the first things we should notice when I have this 4 minus 1/2 I, I can go ahead and multiply. Well, I could use distributive property and just say my denominator here is 4 root 2 minus root 2 over 2 I. Okay, that's my numerator hasn't changed, of course. Now at this point, it might be beneficial to realize, say, hey, wait a second, since I have this written here as a 4 root 2 over 1 basically. I could expand this. I could just say, hey, wait a sec, I'll just rewrite this as 8 over 2 because that's still equal to 4, right? And now I can see that my denominator, and I'm kind of ignoring the numerator right now, and that's fine. We can get away with that. But I now have, let's see, I've got 8 root 2, make this go away for a sec, 8 root 2 minus I root 2. Any guesses what I'm about to do here, by the way, with this? Yeah, I'm going to go ahead and factor that. So first, with respect to that 2, because whenever we have this, this factor of a 2 here, I can treat this whole thing as being, instead of dividing by that fraction, I can multiply by its reciprocal. That is to say, actually, you know what? I'm going to highlight it in red just to kind of show that which fraction it is. It's 2 over, and then I'm going to eventually say root 2 times the quantity of 8 minus I. As you can see, I factored that. Times, what did I say that numerator was? I had it in purple, so I'll write it in purple again. I'll say 2 root 2 plus 1 minus I plus I root 2. See? And that was, what this was here, right here. It's still right here. Well, now it's just this over 1. All right, so this is wonderful. For one of the things I can do next, of course, is I can get rid of that radical denominator. Since I've got a root 2 on the bottom, I'll just multiply both sides of this thing by root 2 over root 2, like that. And then we're going to, let's see, if I do that, of course, I will now have, what is root 2 times root 2? That's just going to be 2, right? And won't that cancel? Why don't I just save myself some multiplication here? And in the end, I mean, now I'm all the way down to z equals, and gosh, I have root 2 times this whole quantity. Okay, fine. 2 times root 2 times root 2, that's going to be 4. And I got 1 times root 2, fine. Minus I root 2, fine. And then plus I root 2 times root 2 is going to be 2I. I have all this over, and I've got 8 minus I. All right, rationalize again by multiplying by 8 plus I over 8 plus I. My denominator, of course, is going to be 64 minus this, minus I squared, which, of course, since it's 64 minus negative 1, I'm just going to have 65 as my denominator. Meantime, up top, I do have a lot of multiplication to do. 8 times 4 is going to give me 32, fine. 8 times root 2, fine. Minus 8I root 2, okay. 8 times 2I is 16I. And then I still have all the i's to multiply, so it's going to be plus 4I. But as you could hopefully see already, I'm going to have some like terms in here that I can reduce. And let's scoot this over just a bit. There we go. And continue with the multiplication here. I times, let's say I had 2 to go. I times the minus, that's minus, I squared root 2. Wait a second, I squared, that's negative 1. This whole thing right in here is just going to become plus 1. Plus 1 times root 2. Oh. And then I times 2I on the end plus 2I squared is going to be negative 2. And now we'll just go ahead and simplify where we can. Hopefully you've kind of picked up on how 32 and negative 2, that's going to equal 30. And what else do we have in here? I'll use a different color highlighter. Let's see, I see an I root 2 right there and a minus 8I root 2. When I combine those like terms, I'll have a minus 7I root 2. Looking pretty good. I have 16I plus 4I, that's 20I for sure. And finally, I have one more highlighter pen here. Root 2, 8 root 2. And that's going to add up to 9 root 2, like so. And now usually, we like to try to put the real number parts together, even if it's going to be all busted up like this into different parts, but I have I in 2 different spots, I suppose, and you could also write it as, with the I factored and so forth. But at the end of the day, when I'm writing this, I need to recall that my answer space here, I can reduce this, where possible. And again, as I said, we like to have this, A plus BI form. So this is going to be my A, and this will reduce the 30 portion, I can cut that down to 6 thirteenths. 30 over 65 is 6 thirteenths. And then I've got 9 root 2 over 65. That's not going anywhere. But this is the portion that is the A part. And then the BI portion, as you can see, once I've factored out the I will have, let's see here. I've got 7 over 65. That's not going anywhere. So I'm just going to have a minus 7 root 2 over 65, while the 20 over 65 portion reduces to 4 over 13, since there's a common factor of 5. All right, and it's going to do the end of that. That's going to be the end of that problem, and I will catch you guys later. Hope to see you soon. Bye.